Hey guys, hope you had a great weekend. Again, sorry I can't be there. I am having a great time serving in jury duty, I am sure. But since I am not there, hopefully this video will be instructional and you'll learn something. So what we're going to start talking about today is actually sketching the graph of our polynomial functions using technology. We're no longer just going to be guessing at some of the characteristics by hand, but we're going to be creating a precise graph where we can actually know all the characteristics. Oh, wait, but Mitchell, yes, there is a catch. All right, there is one characteristic we cannot find using graphing technology, and that is our imaginary zeros, right? If we look at graph A, you can see we have 3 clear real zeros because the graph crosses the x-axis 3 times. No problems there. But in B, we can see there's only 1 real zero because the graph only crosses the x-axis once. However, B has a degree of 3, and just like we talked about, the degree has to match the number of zeros. Since it's a third degree, there have to be 3 zeros, so that leaves us with 2 zeros unaccounted for. The reason they are unaccounted for on the graph is because they are imaginary zeros. So this leads us to a question. If we can't find the imaginary zeros by graphing, how do we find them? Well, I'm glad you asked. The answer is our best friend, synthetic division, and his sidekick, the quadratic formula. And just in case we don't remember the quadratic formula, the x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. All right, you can unmute it now and actually listen to me again. But what we're going to be doing is using both of those. As long as we know at least 1 real zero, we can use synthetic division to divide our polynomial down to a quadratic polynomial, and then use the quadratic formula to find the last 2 real zeros from that. All right, so let's take a look at an example here. So we have a third degree polynomial function here, and we're told that 1 real zero is -8. So what we're going to do is we're going to perform synthetic division, and we're going to put -8 in the little half box up to the left. Then we're going to write out our coefficients: 1, the leading coefficient, 9, 6, and -16. Now, if -8 is a zero of this, one thing we are going to be able to see for sure is that you will have no remainder. Anytime a number is a real zero of a polynomial function, when you perform synthetic division, the remainder will be 0. All right. If you end up with a remainder, then the number is not a zero of the polynomial function. So if we proceed here, I'm going to bring down. Let me set up my lines here. I'm going to bring down my 1. I'm going to multiply. -8 times 1 is -8. 9 plus -8 is 1. -8 times 1 is -8. 6 plus -8 is -2. -8 times -2 is 16. And what do you know? X is 0. So now we've divided this polynomial by a degree of 1, which again, we use these coefficients. 1 less degree, so 1 down from a cubic would be a quadratic, from x to the third to x squared. So then this next one is positive x, 1x, and then this last one is my constant. So I've gone from a cubic polynomial function now to a quadratic function. And now I can use the quadratic formula, right? A here equals 1, B equals 1, and C equals -2. And my other 2 zeros, x is going to equal the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times 1, right? And 2 times a there. So when we simplify this, we're going to get -1 plus or minus 1 squared is 1, minus 4 times 1 times -2 is -8. So that's really 1 minus -8, which is 1 plus 8, which is going to give me 9 over 2. So the square root of 9 is 3 over 2. So now I have to do -1 plus 3 divided by 2 and -1 minus 3 divided by 2. -1 plus 3 is 2. 2 divided by 2 is 1. -1 minus 3 is -4. So this top part here, I'll just put, it can be 2 or -4, right? We simplify it. and that will give me negative 2. So my zeros are the original 0, negative 8, and then we actually did, in this case, end up with 2 more real zeros, 1 and negative 2. So this is an example of how we can use synthetic division and the quadratic formula to find all of our zeros if we are dealing with these polynomial functions here. All right. So down below on the next page of your notes is just examples practicing it. So what I want you to do is pause the video, try to find all the zeros, and then check to see if you did it correctly. All right. So I'm just going to give you kind of a pause between each one, so you can kind of pause and give me that time. So, all right. So let's see how we did. So we put negative. We put negative 7 in the box. 1, 7, 4, 28. Synthetic division, 1, negative 7, 0, 0, 4, negative 28 is 0. I end up with x squared plus 4. My quadratic formula, opposite of b, which is 0, plus or minus b squared, which is 0, minus 4ac. So that's going to end up being negative 16 all over 2a, so 2. So what I'm left with here is really plus or minus the square root of negative 16 over 2. Well, remember, the square root of negative 16, we have to pull out the I, and then the square root of 16 is 4. So what I really end up with here is plus or minus 4i over 2. Well, positive 4 divided by 2 is 2, and I still have the I, and negative 4 divided by 2 is negative 2. So there we go. So negative 7, positive 2i, negative 2i. Remember, we talked about this imaginary zeros always come in pairs. So we can see there's 2 of them. All right, so pause. All right, let's check this one. 4, we got 1, negative 9, 14, 24. Synthetic division, 1, 4, negative 5, negative 20, negative 6, negative 24, 0, x squared minus 5x minus 6. Quadratic formula is 5 plus or minus, let's see, that's going to be 25 minus negative 24, which is going to give us 49 over 2 times 1, which is 2. So that's going to be 5 plus or minus 7 over 2. So my other zeros will be 6 and negative 1 to go. So here we have 3 real zeros on this one. All right, ready? Pause. All right, let's see how we did here. 5, we got 1, negative 5, 17, negative 85. All right, bring down the 1. We get 5, 0, 0, 17. And hey, look at that. That's positive 80, not 80. Positive 85, 0. We have x squared plus 17. All right, quadratic formula. B is 0, so we just end up with plus or minus the square root of 0 minus 4 times 1 times 17, which is going to be 40, negative 72 over 2. All right, so the square root of negative 72 is going to simplify to, let's see, 36, 6 square root of 2. Actually, let's rewrite that here instead of I6. How about 6i square root of 2 over 2? So I can simplify this now because 6 can be divisible by 2. So what I'm going to end up with is plus or minus 3i square root of 2. So there are my 2 imaginary zeros with my 1 real zero. Now, when you get to a 4th degree, you're going to have to do the synthetic division twice, which is why you're given 2 real zeros. And you're not going to go back to the start. You're going to just continue working your way down. So I'm going to start with negative 2. I'm going to save a little space here. 1, negative 3, negative 1, negative 27, negative 90. All right. 1, negative 2, negative 5, 10, negative 9, 18. What did I do wrong here? Oh, that's a positive 9, so that's a negative 18. There we go. Negative 45, 90, and 0, right? So then what we're going to do is we're just going to take our next, because right now we have gone, at this point we've gone from a 4th degree, and we'd be at a 3rd degree, but we need a quadratic. So we're just going to do this again. Why am I not writing here? Come on. Come on, pen. There we go, 5. So I'm just going to do it again with the coefficients I got from the first synthetic division. All right. Actually, I should put the line here now. Let's erase that line. All right. So 1, 5, 0, 0, 9, 45 is 0. So we have x squared plus 9. So again, quadratic formula. If you do it out here, you should end up with x is equal to plus or minus 3i. So there's my two imaginary with my two real zeros. All right, do one more here. Negative 4, 1, negative 4, negative 15, 68. Okay, 1, negative 4, get negative 8. That's 32. 17, negative 68, 0, x squared minus 8x plus 17. So if we do this here, 8 plus or minus the square root of 64, when we have minus 72, 64 minus 72 there, right, all over 2. So that's going to give me 8 plus or minus the square root of negative 8 over 2. So I simplify the square root of negative 8. 8 plus or minus 2i square root of 2 over 2. And I can simplify a 2 out of all of those. And I'll end up with 4 plus or minus I square root of 2. So there are my two imaginary zeros. And there is my real zero. All right, one more where we've got 4. Now notice I gave you the zeros as kind of one looking number here, positive 1 and negative 1. So let's start with 1. So 1, negative 5, 5, 5, negative 6. So 1, 1, negative 4, negative 4, 1, 1, 6, 6, 0. Good. And then we're just going to repeat the process there with the coefficients we have again. So 1, negative 4, negative 5, 5, 6, negative 6, 0. Boom. X squared minus 5x plus 6. So we end up with 5 plus or minus 25 minus 24. Right, that's going to be an easy one, over 2. So we end up with 5 plus or minus the square root of 1, which is just 1 over 2. So 5 plus 1 is 6. So x is going to equal 3. 5 minus 1 is 4. X is going to equal 2. So this one, we ended up with 4 real numbers. Positive 1, negative 1, 3, and 2. All right, so we just kind of went through a bunch of these examples. If we're not understanding this, please ask questions tomorrow of either myself or Mr. Alt. Give it a try on the homework. Come to class with questions. We will have somebody there who can work with you. Hopefully me. Hopefully I'll be done with jury duty. But if not, we'll make sure you guys have somebody to work with. All right. Hopefully I'll see you tomorrow. But if not, sometime in the near future.